Okay. Good morning, everybody. My name is Santhosh. I have around 21 years of experience in dealing physics. This is my electricity video. So this will be useful for CBSE 10th class and SSC 10th class and all, and also for all major boards. Okay, maybe Karnataka or Maharashtra, whatever it is. And one more thing, this electricity topic will become a basic for 11th and 12th. Even I make 11th and 12th and IIT and NEET videos also. The point is, see, since this forms a basic concept, and thereby it will be easy for you to understand the electricity concept which you will get in 12th class, that is inter second year, like that. Okay, now see, to save the time I wrote already and kept it ready for you, but next time onwards I can write after explaining this. See, what is electric charge? First of all, see, the property of the material means electric charge definition you can write in two ways. So one, see, one is I wrote or here. Okay, so the property of the material due to which it produces and experiences both electrical and magnetic effects. Okay, that is one definition. Another one is, for example, there is a some charged object like this. If you are bringing a small particle near to it, for example, imagine something like small object you are bringing which has some charge. So then due to this charge, either this small object may undergo either repulsive force, or for example here there is some charged object like this. Some you can take it as some plus q or something. You are bringing some charge, for example you may bring some small q or small plus 1 coulomb, etc., for example. So when you are bringing near to it, what will happen? Compulsory, when you are bringing near to it, it will experience some repulsive force, right? For example, you are bringing opposite charge, for example negative charge you are bringing, then what will happen? It will experience attractive force. So a particle experiences a force, means either attractive or repulsive, okay, when brought into the electric field, is called as what? Electric charge. So these, out of these two definitions, anything you can write. Another one. So now coming to the next, see, electric charge. Okay, that is means electric in the sense which is related to some charge. Okay, and when you say current, electric current means electric means some charge. Okay, and current means actually the motion. Okay, motion means motion, movement of objects, like that. So particles, etc. So here what the rate of flow of charge you can say, because when you say the word rate, it means that with respect to time. For example, in mathematics also we will say the rate of flow of water, etc., for example. Okay, so it means how many liters of water flowing in 1 hour, etc., we can calculate. In the same way here, rate of flow of charge means charge divided by time with respect to time. And here another way you can define this charge flowing per unit time also you can define. The reason why I will explain you. See, that the reason why I didn't write is I want you to understand this definition. Okay, this definition by numbers. See, whenever you write some charge, for example I am writing according to the formula I is equal to q by t. For example, according to the formula I is equal to q by t, I am writing the 100, for example 100 coulombs of charge is flowing, say in some 20 seconds or something like that, 20 seconds. So what I will do, if I cancel that, 21 ja 25, okay, so 25, it means that 5 coulombs per 1 second it is happening, right? So it means that the denominator is going to become 1. So that is the reason it means that for 1 second how much charge is flowing, that is nothing but the current, right? So that is the reason you can say the charge flowing per unit time. Unit time means here what you can write in brackets 1 second. 1 second. So in that way. So another way you can write the definition for current, and the formula for current is I is equal to q by t, where I is current symbol and q is charge symbol and t is a time symbol. Okay, if you students, if you want, you can write also. For example here whoever want, you can write, see, generally current, current. Okay, and this is charge symbol. And see, the reason why I didn't write here is actually charge I mentioned here, and t is time. Okay, of course t is time. And so, and one more thing here, when in a circuit, generally whenever we take a circuit, actually in the wire, generally the number of electrons will flow. For example, consider this as a circuit. For example, I am drawing one circuit example. Okay, for example here you have a bulb, for example. Okay, you have a bulb. Okay, bulb generally according to the CBSE, this is a symbol they give. Okay, so larger line is plus, smaller line is minus, and this is tab key. Somewhere here you can keep ammeter. Okay, and like this you can generally do. And look at here. So see, generally current is taken from plus. Okay, this is I. So I, okay, current is taken like this. This I will go. Okay, this current will be going from I. So when it means that current is taken in the opposite direction to the direction of flow of current. And generally when you take like this, for example, this is a circuit, okay, for example, call this as point A and call this as point B, for example. Now what I am saying is, when the current is flowing from A to B, so you can take the direction of current as I, okay. But electronic direction means this is nothing but conventional direction, means scientists thought that the current is due to the flow of electrons, so your flow of positively charged particles, so they took from plus. But actually later scientists realized that the current is due to the flow of electrons. So what you have to do, you have to keep like this, means actually current is due to flow of electrons only in the solids, especially like conductors. So you can say this as electronic current, you can keep it as from B to A, right? Now coming to the next, this unit, SI unit of current is 1 ampere, okay, ampere, okay, and 1 ampere definition you can write as 1 coulomb per 1 second. And here you write SI unit of current, you can write it as ampere. And when you write the this ampere is the unit given in honor of the scientist, okay. So if a question is given in the exam, you have to write capital A as the answer, or otherwise you have to, when you write the full name, you have to write with small letter, okay. Okay, you should not write the units named in honor of the scientist with capital. When you write as a full name, that time you have to use small letter, lowercase alphabet, okay. If you write only symbol, then you have to use capital, okay, that's it. So and this definition and all I'll explain you. Just let me rub it now, right.